Humans have basically become cosmic stalkers. We stare at the stars like they're celebrities on a dating app, swiping left on ignorance and right on mysteries, and, well, we keep sending rockets at the sky like love letters, hoping for a reply. We bombard the night with questions. Are we alone? What's the meaning of life? Or even who's making dinner on Mars tonight? All the while, the universe just sits there in stoic silence, probably snickering at our goofy obsession. Truly, it's a one-sided interstellar romance. And hey, if we can't get an answer from the cosmos, at least the view of those twinkling lights is pretty spectacular. Long ago, astronomy was more myth than math. Ancient peoples believed the sky was run by gods. Egyptians worshipped the sun god Ra and aligned pyramids with the stars. They had even figured out a 365-day calendar and used star charts to predict the Nile's flood. Babylonians tracked planets and comets with base 60 math and turned celestial events into omens. It was all like telling stories about dragons and chariot races in the heavens. Then the Greeks arrived, turning stories into, often wild, science. Aristotle, in the 4th century BC, insisted Earth was a perfect sphere and the heavy center of the universe. In his model, earth and water, the heavy stuff, sunk to center, while air and fire, the light stuff, floated above. Imagine the schoolyard Aristotle placed Earth in the middle of a giant merry-go-round and made everyone else orbit around it in perfectly circular paths. Centuries later, Claudius Ptolemy, in the 2nd century AD, did the same with extra complexity. Using data from earlier astronomers, even Babylonian records, he built the Almagest, the era's ultimate astronomy textbook. Ptolemy's version of the heavens was like a cosmic physics fair. Every planet moved on little circles called epicycles, which themselves rode on bigger circles or deferents around Earth. The illustrations must have been dizzying. Picture someone trying to hula hoop with 5 hoops on top of each other. This made predictions work, but it was a mess. Still, a few Greeks played with ideas. Eratosthenes, way back in 240 BC, famously measured Earth's circumference using just shadows in 2 cities. And Aristarchus of Samos even estimated the size of the Earth and, well, pondered a sun-centered system. But tradition held Earth as king. In those days, cosmology was like a strict teacher, Earth at the desk, and everyone else going in circles around it. The real drama started in the Renaissance. In 1543, a Polish cleric named Nicholas Copernicus dared to dethrone Earth. In De Revolutionibus, he placed the sun at the center and had Earth whirling around it. Suddenly, Earth wasn't the star of the show, it was just another planet doing laps. Copernicus even got Earth spinning on its axis for day-night cycles and tilting for the seasons. It was like someone telling the school bully, "You might not be so special, buddy." Around that time, Tycho Brahe measured the stars and planets with crazy precision but still hedged between models. His protege Johannes Kepler finally threw out perfect circles altogether. Kepler found that planets move in ellipses, so orbits became cosmic racetracks. No more ballet-like circles, their planets were now race cars on ovals. This fixed Ptolemy's math chaos. Instead of infinite epicycles, there was one neat oval. Next up, Galileo Galilei in the early 17th century gave astronomy a serious upgrade by building a powerful telescope. When Galileo peered at Jupiter in 1610, he spotted 4 moons dancing around it, proof of concept. Here was live evidence that not everything revolved around Earth. He also saw sunspots, Saturn's weird shape, and mountains on our moon. Shocking imperfection up there. He published these findings in the Starry Messenger. The Church, however, still insisted Earth was the immovable center. Galileo's support of Copernicus got him into trouble. He was tried for heresy in 1633. Under threat of torture, Galileo famously recanted and supposedly muttered, "Eppur si muovi," that is, "and yet it moves." He spent his last years under house arrest. It took more than 300 years, but in the 1990s the Church finally admitted, yep, Galileo was right. While Galileo's trial story played out, the physics hero Isaac Newton in 1687 delivered the knockout punch. In Principia Mathematica, Newton laid out the three laws of motion and universal gravitation. Remember the legend of the apple falling on his head? Whether or not it's true, Newton's apple was a metaphor. Gravity was no longer a mystical push from Earth's center, but a force acting between any two masses. Newton's math showed exactly how planets orbit in ellipses, combining Kepler's work with his own laws. In short, the same gravity that makes apples fall also makes the moon orbit Earth, and Earth orbit the sun. People began to see the cosmos as a giant clockwork machine governed by math, which was, well, a far cry from mythic gods. The 1800s brought yet another revolution, this time using light. Astronomers realized starlight carries chemical clues. Joseph von Fraunhofer first noticed dark lines in the solar spectrum, and later Bunsen and Kirchhoff invented the spectroscope. They showed each element leaves a unique fingerprint in light. By 1860, they had discovered new elements via starlight. In effect, we learned the stars are made of the same stuff as us. This felt a bit like finding out your celebrity crush likes the same band. Suddenly, the distant stars felt less alien and more familiar. Spectroscopy opened up astrophysics. We could now analyze atmospheres of stars and planets without leaving Earth. Then came the 20th century, and with it the greatest headline, Relativity. Albert Einstein first reshaped space and time in 1905, then stunned the world in 1915 with general relativity. He told us gravity isn't just a force, it's curvature of space-time. Picture space as a stretchy rubber sheet. Put the sun on it and planets roll along the dents. Einstein's theory predicted light bending around mass, which was proved by the 1919 eclipse, and even warped time. So, if you left for a round-trip space journey, you'd age differently than those on Earth. In relativity, the universe stopped being a static Newtonian clock and became a dynamic, flexible fabric. This paved the way to understanding black holes, where space-time dives to infinity, and a Big Bang origin with expanding space-time. Speaking of expansion, Edwin Hubble in the 1920s blew the lid off our cosmic address. First, he pointed the 100-inch Mount Wilson telescope at the Andromeda Nebula. Using Cepheid variable stars as distance markers, he showed Andromeda was far beyond the Milky Way. It was another galaxy entirely. Up until then, we assumed the Milky Way was the whole universe. Hubble expanded our ego and our galaxy count from 1 to millions. He then measured other galaxies' speeds and discovered they're all racing away from us. The universe is expanding. In one stroke, he helped birth modern cosmology, the Big Bang theory, since the expanding universe implied a dense, hot beginning, and the realization that the cosmos is far bigger than anyone dreamed. Quantum physics was unfolding at the same time, adding its own oddities. The bizarre idea that particles can be waves and vice versa helped explain how stars shine, since nuclear fusion runs on quantum rules and E equals mc squared, why white dwarfs don't collapse thanks to quantum pressure from electrons, and why radioactive atoms vary due to quantum tunneling. As telescopes probed extreme environments, quantum rules had to be invented. We got Bose-Einstein condensates, neutron stars, and even hints at dark matter, which is, a mysterious substance inferred from galaxy rotations. Dark energy, an unknown force accelerating expansion, would come later in 1998, showing the universe still holds surprises. By the late 20th century, astrophysics had melded it all into a thrilling picture, a Big Bang cosmos of spacetime, made of familiar atoms, though 95% of it is unknown dark stuff, with strange quantum and relativistic rules. We launched space telescopes to match our new understanding. The Hubble Space Telescope, launched in 1990, took advantage of this legacy. With a 94-inch mirror above the atmosphere, it captured the most dramatic photos of deep space. In fact, Hubble's launch was the most significant advance in astronomy since Galileo's telescope, dramatically changing how we see the universe. It gave us deep-field images showing thousands of galaxies in what looked like empty patches of sky. Now, our newest eye on the sky is JWST, the James Webb Space Telescope. Launched in 2021 and parked 1 million miles away, Webb peers in infrared at the first luminous glows after the Big Bang and the birth of solar systems, even those that might host life like ours. It's basically the sequel to Hubble, extending our vision further back in time and seeing through dust where Hubble can't. Each step in astrophysics rewrote the cosmic script. From Aristotle's perfect spheres to Einstein's warped space-time, we've gone through the greatest plot twists imaginable, often with, a wink of irony. For example, Galileo gave us his best evidence, and the church hid from it for centuries. Newton's church clock universe ran smooth until Einstein poked fun with bent clocks and stalled motion. Today we understand galaxy clusters, cosmic microwave background, and even gravitational waves. We heard them in 2015, vindicating Einstein again. All these breakthroughs also spurred technology here on Earth. The engineering of space telescopes yields everyday spin-offs. For instance, detectors developed for Hubble are now used in the fight against breast cancer. Hubble's super-polished mirrors even helped polish Olympic speed skates. Its infrared camera technology helped experts read ancient Dead Sea Scrolls. Even a paint-matching gadget in hardware stores owes a trick to Hubble's camera filters. Astrophysics completely reshaped our view of the universe. No longer was Earth the quiet center. It's a small planet orbiting a typical star in a vast sea of galaxies. We found out the universe has a beginning and perhaps an end, that time and space are malleable, and that reality has quirks, dark matter and quantum weirdness that we still don't fully grasp. These insights trickled into technology too. GPS navigation in smartphones only works because we correct for relativity. Space tech gave us solar cells, CCD cameras, and even better weather forecasting satellites. The giants of astrophysics, like Hubble and Webb, continue to test and refine our physics in ways that spill back into engineering and computing. Missions like the Hubble Space Telescope and the James Webb Telescope are, the direct descendants of this long journey. Hubble has been in orbit since 1990, continuously sending stunning imagery back to Earth and helping answer questions about the age and content of the universe. The JWS from 2021 onwards is now doing similar work at infrared wavelengths. Each of these missions is a testament to centuries of astrophysics. The telescopes themselves are enormous, precise feats of science perched in space, all to give us a clearer picture of the cosmos. In everyday life, instruments and techniques born in astronomy keep benefiting us. The charge-coupled devices, or CCDs in telescopes, are now in our phone cameras. Algorithms for star matching can track endangered whale sharks, and honestly, who would have guessed that staring at stars could help with medical imaging? From finding planets around other stars, exoplanets, to deploying satellites that beam live television, our universe curiosity has been a surprisingly practical boon on Earth. So here we are, the third act of a cosmic comedy. After centuries of sending probes and questions skyward, we've learned almost everything about galaxies, except where all the missing socks go. It's the universe's ultimate punchline. Our quest to understand space has answered a million big questions and revealed a million more. But sometimes the greatest mystery is right at our feet. We still can't figure out why the television remote vanishes or how to fold a fitted sheet. In the end, the universe keeps playing coy. It has revealed that we orbit a random star in one galaxy of many, and yet it keeps its answers close to the chest. Maybe that's fitting. We cracked gravity and cosmology, but figuring out household chores remains an unsolved problem. So as we continue to explore the heavens, we remember that the grandest journey of all is balancing our cosmic dreams with everyday life, and that maybe, just maybe, the universe is chuckling all along, knowing we humans are in for the ride with laundry on the side. After all, it's one wild, wonderful story, from mythic skies to space telescopes, and it's still being written.